Today we've got a story for you about a multi-million-dollar military project that just failed, completely and spectacularly. And it's way more than just a cool piece of history, because it holds this incredibly powerful lesson about innovation, shortcuts, and, the hidden dangers of copying something without really understanding it.
I mean, we all love a good shortcut, don't we? It's that feeling of finding a faster way to get the right answer, a quicker path to success. It's all about efficiency, right? It's like someone else has already drawn the map and all you have to do is follow it.
Yeah, what if the very thing you're trying to copy is, broken from the start? That's exactly the kind of high-stakes gamble we're going to dive into today. And believe me, it went wrong in a big, big way. All right, so let's meet the star of our show, the Japanese G5N Shinzan. Now, in the super tense years leading up to World War II, this plane was supposed to be a massive technological leap forward. It was meant to be a symbol of Japan's incredible, growing air power.
Just think about that for a second. Its one job, its entire reason for being built, was to fly really far and drop bombs. But instead, it was so fundamentally flawed, so ridiculously heavy and underpowered, that it ended up just hauling supplies. Talk about a failure of epic proportions.
So that's the big question, right? How on earth does that happen? This wasn't some small mistake. It was a huge investment of time, money, and some serious engineering talent. To really get it, we've got to rewind and see where this whole idea even came from. And funnily enough, the story doesn't start in Japan. It starts in America. See, Japan knew it needed a powerful long-range bomber, but building one from the ground up, that would take years. And this, right here, is the crucial piece of the puzzle. On one side, you have Japan's very clear military goal. On the other, the perfect solution they found, the Douglas DC-4E. Now, this wasn't a bomber. It was an American airliner prototype that had already been rejected by American Airlines because it was too complicated, too heavy, and way too expensive to run. It was, for all intents and purposes, a known failure.
But here's the thing. Japan didn't know the whole backstory. They just saw this big, beautiful, state-of-the-art 4-engine plane and thought, that's it, that's our shortcut. So they bought the one and only prototype for almost $1 million, which was an absolute fortune back then, thinking they'd just bought the future of aviation.
Okay, so they've got the American plane. Now what? Well, Phase 2 begins. The plan seems simple enough. Take it apart, piece by piece, measure absolutely everything, and then just build an exact copy, but, for the military.
And you got to give them credit, they did an incredible job of it. These engineers were masters of imitation. They documented every single rivet, every structural beam, every curve of the metal. If you were just looking at the physical object, their work was flawless. They were creating a perfect clone.
But here's the problem, and it's a huge one. They had the what, the physical airplane, but they were completely, totally missing something way, way more important. You see, the engineers had copied the hardware, but they hadn't copied the software. And I'm not talking about computer software, of course, but that critical human knowledge, the experience that went into creating it in the first place. This all comes down to a concept called institutional memory. Think of it like this. It's all the lessons you learn from trial and error. It's the notes from failed experiments, the late-night arguments between engineers about why some design idea was just a total dead end. It's the why behind the what. So, for instance, the Japanese team could see the shape of the fuselage, no problem. But what they couldn't see were the meeting notes about the design compromises that made it so heavy. They copied the wing assembly perfectly, but they didn't have the stress test data showing it was likely to crack. They copied where the engines went, but they missed the pilot reports that said it made the plane dangerously unstable. They copied the answers, but had no idea they were the wrong answer. So you can see how this becomes a recipe for absolute disaster. Step 1, start with a bad design. Step 2, copy it perfectly, which means you lock in every single invisible problem. And then step 3, you make it even heavier by adding armor and bomb bays. The final result was practically inevitable. A plane that could barely even get off the runway, let alone be a strategic bomber. This whole episode gives us this fantastic term for what happened: mechanical irony. It's just the ultimate paradox of imitation, isn't it? The more perfectly you copy a flawed thing, the more perfectly you guarantee your own failure.
Now, you might be thinking, okay, that's a pretty neat piece of military history, but the real power in this story is just how relevant it is right here, right now, for all of us.
It's a lesson that goes way beyond engineering or war. It's really about the fundamental difference between just imitating something and actually innovating, between just seeing and truly understanding.
Seriously, think about it. You see this everywhere. You see startups that just clone a competitor's feature without knowing any of the user research behind it. You see students who copy and paste code from the internet without having a clue how the algorithm actually works. Businesses that mimic a viral ad campaign without the market data that made it work in the first place. It's always the same mistake, copying the what and totally missing the why.
And really, it all boils down to this. The real magic isn't in the final product itself. It's in the process, the experience, the knowledge, that institutional memory that created it. Real progress, the stuff that lasts, comes from learning, not just from cloning.
So the next time you're looking for a shortcut or you're trying to replicate somebody else's success, just ask yourself this one question. Are you really digging deep to understand the principles that made them successful, or are you just painting a perfect copy of a plane that was never, ever meant to fly